All right, now we're going to actually find the zeros. Now we're going to use the rational zeros theorem to help us. So notice step one, when we're finding our rational zeros, step one still says that we start with just listing all of the possible rational zeros. So let's do that. So just like we did in the last examples, we're just going to find all the factors of 8 and divide them by the factors of 1. Oh, even easier. Okay, so I'm going to do that first. All the factors of 1 are 1. Factors of 8 are 1, 2, 4, and 8. So this is nice. I just have to divide them by 1. So basically all I'm going to do is write all the plus or minuses. So we have plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So there's only 8 numbers that could possibly be rational zeros. Now, what we're going to do is we're going to actually factor this, just like we did last lesson. But if you'll remember last lesson in 7-4, we gave you one factor. Like they'd write up here, x minus 4 is a factor. And then you'd factor it out and find the rest of them. So this time they didn't give us anything. And I don't know if x minus 4 really is 1. We have to find them. Now remember the factor theorem as well from last lesson said if we divide by one of these zeros, if we divide this polynomial by a 0 and get the remainder 0, then we can say that it is a factor. So that's what we're going to do. Basically, you're just going to test all of these, hopefully just one. Hopefully you're a really good guesser and can find a 0 on the first try, and then we're going to completely factor it. So I always tell my students, start with 1 and -1. Most of the time they are a factor, but even if not, they're the easiest ones to try. So we're just going to try 1. We put 1 in the half box, and then we're going to write all of our coefficients here. So we got 1x to the third, 3x squared, -6x, and -8. All right, 1 drops straight down, 1 times 1, 3 plus 1, 4 times 1. -6 plus 4 is -2 times 1, -2, and that does not give me a 0. Oop, did not work. So we're going to erase all this. Hopefully you've got an eraser close by. Look at how easy it is for me to erase. And we're going to try -1. Okay, so it's not +1. You can maybe cross that off if you want to, but we're going to still try -1 before we cross off all of the ones there. All right, 1 still drops straight down. 1 times -1 is -1. 3 minus 1 is 2. 2 times -2 is -2. And -6 minus 2 is -8. -8 times -1 is +8. Oh, look at what we have. We have a remainder 0. This should make us all jump up and down for joy. This is fantastic news. Okay, so now what we're going to do is we're going to write this in factored form. Now, they didn't give us a factor. Again, remember, usually they write a lovely little x plus something or x minus something. If we know that -1 is my 0, that means that this, if you plug in -1 to the function, you get 0. You can write it as a linear factor. Basically, you just switch that sign. You just say x plus 1. That means if you put in this -1 for x, -1 plus 1 will give you a 0. Okay, and then we're going to bring down our x's. Remember, if this is the next to the third, when I divided by my x plus 1, this one represented the number of x squareds I have. That 2 is the x's, and then just that 8. So I've got an x squared plus 2x minus 8 right here. Whoops. It's thinking minus 8 as its factor. It's going away. There we go. All right, now once you get it to a squared, your job is so much easier because you don't have to keep guessing. Once we get some of these examples, we use x to the fourth, and sometimes we have to guess more than once. We have to guess another 0, but if you get it down to a quadratic equation, go ahead and just factor this. We know how to do this. We're looking for two numbers that multiply to -8, but add to +2. They are, you got it, they are 4 and 2. We're going to make it a +4 and a -2 so that 4x minus 2x gives us a +2x. All right, so this is, that is factored form. However, that is actually not what they asked us to do, so we're going to keep going. They want us to find the actual zeros. Okay, so this factored form helps us to be able to identify the zeros. Now it's easy to see. What would give me a 0 here, or what did give me a 0 up here? Yes, -1. Just change the signs. A -4 plus 4 will give me a 0, and a +2 minus 2 will give me a 0. So there are 3 zeros. Remember, fundamental theorem says there can be at most 3 real zeros right there. Okay, let's try this next one. Again, we do the same thing. I forgot to point out the steps. We tested the zeros. We're trying to find a 0 right here and then factor. Okay. All right, let's go on to our next one. We're going to look at all the factors of our last number. Notice right here, I'm actually going to even just skip this step because I have a 1 in the denominator. So I don't even need to write the divided by 1 because they're all going to just be factors of 20. So I've got plus or minus 1, plus or minus 2, 4 will divide into 20, 5 will divide into 20, 10, and 20. Again, there's quite a few here. We're just going to go ahead and pick one. Again, I usually start with 1. Be careful, guys. They've got a missing term here. Do not let them trick you. You've got 1x to the third, but 0x squared, -21x, and +20. All right, 1 drops straight down. 1 times 1 is 1, plus 0 is 1, times 1 is 1. -20 plus 1 is -20, times 1 is -20. Oh, look at that. We got a 0 for my remainder on our first try. Isn't that fun when that happens? All right, so we know that 1 gave us a 0, so we're going to write this as our linear factor. Well, let's change to orange here. So we're going to write this as f of x is equal to, and then if +1 gives us a 0, we're going to write an x minus 1, just so that when we plug in our 1, subtract 1, we get our 0. All right, then we're going to remind ourselves what these numbers represent. If we started with an x to the third, this is an x to the second. That's my 1x minus 20, so I've got x squared plus x, subtract 20 right there. And again, once you get it to a quadratic, if you see that squared right there, factor away because it's lots easier than trying to guess another one. All right, to factor these, remember your first terms here multiplied to x squareds are both going to be x's. Your last numbers have to multiply to a -20, but add to +1. There's 1x right there. So we know, you all know, that 5, a +5 and a -4. So 5x and -4x will give us that +1x. Good. All right. Now, again, I kind of circled the answer last time, and we'll circle the answer again, but this isn't what they want. They actually want the zeros, the numbers that if you plug in right here will be the x-intercept or the y is equal to 0. All right. So we just have to go through and say, okay, plug in a 1. So +1 will give me a 0. A -5 will give me a 0. And a +4 will give me a 0. Those are my 3 zeros. All right, we're going to do one more example in this video, but it's not the next one. We're going to skip down because this one is also degree 3. Okay, then the rest, all the degree 4s we'll save for the next video, but we're doing another degree 3. It's the same way that we did the others, so nothing new to teach you. We're going to take all the factors of 10. This time, though, we have to do it in the bottom. So we've got 1 times 10, 2 times 5 times 10. So those are all my factors of 10, and 1 and 3 are factors in the denominator. So this means I could have a positive or -1. We'll circle that one. So 1 divided by 1 or 1 divided by 3. Those could all be factors or zeros, or 2 divided by 1 could be a 0, or 2 divided by 3 could be a 0. 5 divided by 1, 5 divided by 3, or 10. So 10 or 10/3. Right there. So those are our possible rational zeros. Now we have to test them. Again, we're trying to get the remainder to be 0. If we can get the remainder to be 0, then it's a 0 and we have it. Whoops. We're waiting again. Give us 2 seconds. It doesn't pop right back up. We will try